Alright, here we go, iChem lesson 18, empirical molecular formulas. This will be our last iChem for the unit. Make sure you have your viewing guide and you're taking notes. You'll probably want a periodic table and a calculator to be able to effectively follow along. So first of all, there are two kinds of chemical formulas, really, and we've only so far been talking about the one to the right, molecular formula. This is the actual formula of the compound. Versus the empirical formula is a formula that has reduced some subscripts. The empirical formula actually represents, is related to the percent composition that we talked about yesterday directly. So it's just the ratio of the different atoms within the compound. So here I have a molecular formula for glucose. Is it the empirical formula is the first question. To answer that question, you want to look at the subscripts and see if they are reduced or can be reduced. They're all multiples of 6, so I can reduce this, so that means this is not an empirical formula. If I reduce this, I would divide all the subscripts by 6. I would get CH2O. Now the thing about empirical formulas is there could be hundreds of compounds that have this particular empirical formula, because it doesn't tell you exactly how many of each atoms are in one compound. It just tells you really the ratio of atoms. For every carbon, I have 2 hydrogens and 1 oxygen. Like here, I have, for every carbon, I have 2 hydrogens and 1 oxygen. It's a ratio. So let's talk about how it's connected to that percent composition. And this scenario is something that actually plays out in labs, especially crime scene investigation type things. If you've seen, maybe you recognize Abby from CSI, or no, sorry, NCIS, or you see them in the lab in CSI and they run a sample through the mass spec. If you watch NCIS, you know how much Abby loves her mass spec. And you come out with a answer of what that particular compound is. There's a lot more that goes into it than the show makes out to be, but it's based in the chemistry and in the facts that if you can figure out the percent composition and the molar mass of a compound, you can identify its chemical formula. So the mass spec will give you information like this. It'll tell you it's 40.9% carbon, 4.58% hydrogen, and 54.5% oxygen. We know how to find those numbers now if we know the formula for the compound, percent composition. But now we're going the other way. Given percent composition, can we find the formula for the compound? Another piece of information you need to find the molecular formula is the molar mass. There are billions of compounds that contain carbon and hydrogen and oxygen. Our first thing we need to do is figure out the empirical formula to determine the ratio of carbon, hydrogen, and oxygen, and then we can use the molar mass to find the identity of that compound. And we'll play CSI on Friday and get a lot of practice with this. So, first step is to find the empirical formula. On your notes, there's space for you to write down this rhyme. I want you guys to memorize this because we'll be applying it over and over and over again. So here it goes. Percent to gram, gram to mole, divide by the smallest, multiply till whole. Percent to gram, gram to mole, divide by the smallest, multiply till whole. Say it to yourself a couple of times. Percent to gram, gram to mole, divide by the smallest, multiply till whole. Now let's apply it. First step. Percent to gram. This is the easiest step of all. You literally take the percent sign and write a G instead. So I have 40.9 grams of carbon, 4.58 grams of hydrogen, and 54.5 grams of oxygen. Essentially what we're doing here is assuming we have 100 grams of the compound and pushing forward with our calculations that way. So we're done with the percent to gram. Now gram to mole. We know how to convert grams to moles. We divide by the molar mass. So the molar mass of carbon is 12.01 grams per mole. The molar mass of hydrogen is 1.01 grams per mole. A good rule of thumb is to go out to 2 decimal places. Molar mass of oxygen, 16, and we're just rounding for this one because it goes out to a whole bunch, 15, and a whole bunch of 9s. So now I can plug all of this into my calculator. 40.9 grams divided by 12.01, I end up with 3.41. 4.58 grams divided by 1.01, I end up with 4.54. 54.5 divided by 16, I end up with 3.41. So I'm done with grams to moles. Now divide by the smallest. You have to do all of them to be able to do this step. So I need to look at my answers for all of the moles and find the smallest. Now I have 3.41 and 3.41. They're both the smallest, so it doesn't matter which one I pick. Divide by 3.41. 3.41 divided by 3.41 divided by 3.41. I end up with 1.33, and 1. I completed this step. Now multiply till whole. I need whole numbers to be my subscripts in my formula. So this isn't going to cut it. 1.33. I need to multiply that by a number that will give me a whole number. Look at the numbers after the decimal point and use that to sort of determine. So I have 0.33, which is the same as a third. So I'm going to multiply by 3. And that will give me the whole number 4. So now I don't have a decimal anymore. Because I did that, though, I'm changing my amount of hydrogen by 3. I need to change all of these. So multiply everything by that whole number you decided. So I have 3, 4, and 3. These numbers are the subscripts in my formula. So I have carbon, and I have 3 of them. I have hydrogen, and I have 4 of them. I have oxygen, and I have 3 of them. This is what's called an empirical formula. We will label this EF, not to be confused with the molecular formula. I haven't identified this compound yet. There's still one more step. I'm going to walk you through all of those steps with one more example. So finding the molecular formula. Step 1 is exactly what we just did. Find empirical formula using the rhyme. Step 2 is to check it against the actual formula. You must be given a molar mass. So here I'm given a molar mass of this compound. So first, I'll go through everything that I just went through before. So percent to gram, easiest step in the world. Change the percent sign to a G. 71.65 grams of chlorine, 24.27 grams of carbon, 4.07 grams of hydrogen. Grams to mole. Divide by the molar mass. Find chlorine on the periodic table. I have 35.45 grams per mole. I have carbon, which is 12.01 grams per mole. And I have hydrogen, which is 1.01 grams per mole. Okay, so now plug all of this into my calculator. I end up with 2.02, another 2.02, and 4.02. Just 71.65 divided by 35, 2.02, 24.27 divided by 12.01, 2.02, 4.07 divided by 1.01, 4.02. Done with grams to mole. Divide by the smallest. I have two 2.02s and one 4. 2.02 is my smallest, so I'm going to divide all of them by that. I'm going to get 1, 1, and 2. I don't need to do the multiply till whole number step because I got all whole numbers. Now if I plug 4.02 divided by 2.02 in my calculator, I don't get exactly 2. I get 1.99, but that's close enough to 2. I'd say anything 0.9 to 0.1, those can just be rounded to a whole number, and you can skip that last multiply till whole step. Alright, so I kind of ran out of room here, so I'm going to write it down here. I end up now with an empirical formula of CH2Cl. 1 chlorine, 1 carbon, 1 hydrogen. By habit, I always write my carbons, hydrogen first, and then anything else in the compound last, but that doesn't necessarily really matter. So I need to check to see if this is the actual formula. So you need to be given a molar mass. Just kind of locate that for now. We're going to compare to it in a minute. I'm going to find the molar mass of my empirical formula. So I have 1 carbon, 2 hydrogens, and 1 chlorine. So 12, 1, and 35.45. If I add this all up, I end up with 49.45. Now I'm going to compare this number to this number. I have 49.45 grams per mole in my empirical formula. My actual compound has 98.96 grams. So these are not the same. This is not that. What I want to do is now divide that number by the molar mass that I have. And I end up with 2. That means that my actual compound is essentially 2 of these. So I'm going to take all of my subscripts and multiply them by 2. And I'm going to write it right up here. Kind of all over the place, sorry. I have carbon, originally the subscript is 1, multiply it by 2, give it a 2. Hydrogen, original subscript is a 2, multiply it by 2, I get a 4. Chlorine, original subscript is a 1, multiplied by 2, I get a 2. This is the actual formula for my compound. It's 2 carbons bonded to 4 hydrogens and 2 chlorines. But the ratio of carbon to hydrogen to chlorine is my empirical formula and comes from my percent composition. Make sure you do your Google form, and I will see you tomorrow.